Ladies and gentlemen, I would like to talk about my scientific overviews. Title is Porous Material, Synthesis, Characterizations and Application. You know that in the world, micro, meso, and multiporous materials have been researched intensively because they have many good characteristics and large applications possibilities such as adsorbents and catalysts. In Vietnam, research on porous materials are limited and mostly non-applications in industrial scale. Vietnam has lost a lot of kaolins which can be used as raw materials for synthesis of porous material. Kaolins has two-dimensional layer structure, so it has low porosity and best adsorption catalyst possibility. While zeolites and porous materials have a three-dimensional structure, so they have high porosity and good adsorption catalyst possibility. Both of them have two main components, aluminum and silicon, only different structure. To need to convert kaolins into zeolites and porous material. Scientific ideas to convert cheap and available kaolins to porous materials by using organic complexes during crystallizations and breakthrough solutions about technologies step by step to apply into practice. To convert them, firstly needs to break down layer structure of kaolins, convert coordinations aluminum 6 into coordinations aluminum 4. There are three main research directions. The first, synthesis, characterizations, and applications of zeolites on basis of kaolins used for adsorptions and catalysis in cultivations, breedings, and environmental protection. The second, synthesis, characterizations, and applications of nanozeolites used for ash and car in petrochemical technologies. The third, synthesis, characterizations, and applications of meso and multiporous materials on basis of zeolites and MOF used for N&Ks in petrochemical technologies and environmental protection. Objective and methods of research. Objective have been focused on three main objectives: build up successfully synthetic technologies of micro, meso, and multiporous materials. Develop successfully the applications of in realities. Since undergraduates and graduate students. Contents. I have been focusing on three main contents: research on reactive components, silicon, aluminum, alkali, water, organic linkers. Research on technological parameters, temperature, time. Step-by-step optimized technological processes in laboratories, mass pilot, applies and handovers to realities. Techniques. We have used research methods, HRT, IR, SAM, TEM, BAT, TPD, DTA, TCAs, IIS, and GCMS, etc. to characterize the structure of products. Many results. 1. Synthesis, characterizations, and applications of zeolites on basis of kaolins used for absorption and catalysis in cultivation, breeding, and environmental protection. The result. Synthesize some common zeolites from kaolins in an unconsumed kaolins by hydrogenous crystallization methods as atmosphere pressures which present a organic complexion. This is a basic research directions, semantics and very details about synthesis and characterizations of zeolites from Vietnamese kaolins. By putting organic complexons to break kaolin structures and then recrystallizing new structures of zeolites, that was a breakthrough solution during this research direction. The results are confirmed that we can convert directly unconsumed kaolins to zeolites. It opens up potential possibilities about synthesis and applications of some common zeolites in Vietnam. Catalytic activities of zeolite wires in the cracking of N-heptanes, conversions of N-heptanes and the selectivities of toluenes increase with temperature, whereas the selectivities of gas products decreases. At the same temperatures, the conversions and selectivities of gas products on zeolite wire simple are lower than zeolite wire standards, but the selectivity to toluenes is higher. 2. Synthesis, characterizations and applications of nanozeolites on basis of kaolin, used for absorption and catalysis in petrochemical technologies. The result, from Vietnamese kaolins, synthesized successfully nanozeolites, the former products in endogenous crystallizations for 24 cells at normal condition, crystal size 20 nanometers, and best specific surface area for distribution containing micropores and mesopores. We have used nanozeolite to absorb both doses that achieve good results. The crystal size of zeolite is decreased from micro to nanometer scale, causes appearance secondary mesopores and reduce absorption lines. So absorption probability is better than zeolite is. 3. Synthesis, characterizations and applications of meso and multiporous materials on basis of zeolites and kaolin, used for absorption and catalysis in petrochemical technologies and environmental protection. The results. We have synthesized MSUs from unconsumed kaolins in normal conditions. The former materials has hexagonal structure in order oven holes with thickness of 2 nanometers for distribution 3 nanometers, best specific surface areas. We have used multiporous materials to cheat toxins in cigarette smokes. As a result, reduced nicotine and tars contain respective equals 30% and 20% compared with control experiments. These results open up large applications possibilities by putting absorbents into cigarettes filter tips to reduce nicotine and tar contents helps to protect community health. 4. Catalytic activities of MSU and meso-USY for alkylations benzenes with isopropanol. Benzene conversion and cumin selectivities are very high. MSU is most suitable than meso because it have acidity was more suitable than for alkylation. 5. Synthesis and applications of micro HQ1. Hardcast once microcrystal have been synthesized successfully in room temperatures in ethanol and water. The former materials has crystallized 5 micrometer best surface areas, high spore volumes and containing of medium isolate site. 6. Synthesis and applications of nano ZIP-8. ZIP-8 nanocrystals have been synthesized successfully at room temperatures in methanol. The former materials has crystallized 15 nanometer best high specific area, high pore volumes and thermal stability reaches 400 degrees centigrade. Nano ZIP-8 have been supplied as catalysts for the convergence of BAs and ECAs. Presents the conventions BAs nearly complete after 3 hours. 7. Synthesis and applications of nano ZIP-90. Highlights: for the first time, ZIP-90 was successfully synthesized from zinc chlorides and in a large scale. ZIP-90 can be used as a head store material. 8. Handover of zeolite. Zeolites have been applied in aquaculture, cultivations and breeding fields. Main purpose of putting zeolites to teach environmentals in fisheries pond. Handover technologies to build 2 zeolites factories with 3,000 tons per year scale in Quảng Bình, Vietnam in 2003 and Cần Thơ province in 2006. Zeolite factories in Cần Thơ province has thus promoted to 20,000 tons per year, whose concern the product price was about 60% of import price from Thailand. Future directions of research. In the future, to focus on 3 main research directions. First, step ups applications synthetic technologies of zeolites from kaolins into practice. The second, develops synthetic technologies of nanozeolite, meso and multiporous material on basis of zeolite, kaolins and Ross material in Vietnam and step ups into practice. The third, research synthesis and applications of MOPs and ZIPs. Ladies and gentlemen, about is my presentation. Thank you for the listening.